Hi, this is Professor Brennan back again. We are continuing our discussion about examining statistical evidence or issues with statistical evidence, and we had left off talking about mean, median, and mode, and we're going to just review those really quickly, and then we'll move on to the next piece, and this is for my argumentation class, part 2. All right, put that over there. Okay, so again, mean is the average where you add up all the numbers and divide the number of numbers by that sum. The median is if you were to make a list of all the numbers, it's that middle number in the list of numbers. The mode is the number that is repeated most in the list of numbers. Using these different ways, you need to understand the differences, but using these different things can give us different information, right? So when they say average, what do they mean by that? No pun intended, by the way. Okay, number 5, be careful when you compare percentages. Why would that be important? Well, what percentages are they talking about? And you have to ask yourself, are they comparing apples and oranges? Okay, that old saying. Are the things comparable to begin with? I'm going to give you a great example. A student gave a speech one time in my class about Burning Man. It was supposed to be a not a compare contrast, but I can't think of the name of this kind of speech right now, but the point is she was supposed to compare two things. Well, when you compare two things, they have to have the same derivative. They have to have the same origin. They have to be comparable, okay? She compared Burning Man, and if you don't know what Burning Man is, look it up. You can Google it and find out what that means, to the big concert they have in like the San Bernardino Valley, Coachella. Okay, she compared Coachella, which is a series of concerts over a period of time, right, to Burning Man. They're not comparable. One thing they have in common is music, but even at Burning Man, they don't have bands. They might also have in common drugs. But aside from that, their purpose of being is completely different. They're not really comparable. Now, if you compared Coachella to another, 4 or 5 day concert series, then that would be comparable. Or if you compared Burning Man, I don't know what else is like Burning Man. But it doesn't matter. The point is they have to be comparable. So you can use this example that I've given in here that's pulled from your textbook, or you can just ask yourself, when they compare percentages, are they comparable? Right? Are they relevant? If you compare, just think about this. I mean, this gives you kind of like regions, right? But think about, is it comparable to talk about Californians? Can we compare statistics of Californians versus some other region that might have totally different values? Let's say the Bay Area. We compare them because they're both Californians and they're Americans, or they're residents, at least, of the United States. However, some things aren't. It depends on what you're comparing, right? It depends on what percentages you're comparing, what percentage you're talking about. Is it comparable? Okay. Know whether the arguer is using absolute or relative percentages. Absolute means that's exact. Absolute means exact. Or are they talking relative to something that occurs, right? Is it relative to something else? Absolute means the exact percentage. You have to know, are they talking about the exact number? When they say 76% out of 100, is it 76 people exactly? Or they're talking relative to, is it 76% relative to what happened last year? You have to understand how are they using those statistics, the questions you have to ask yourself. Correlation is not the same as causation. So when you make a correlation between things, what you say is they have a relationship with each other. It doesn't mean they caused each other, but there's a relationship. And actually this example is a really good example. So it's example of aging in prune juice. So I'm gonna get graphic. We're just gonna use this, and you all can laugh about it. But so when you age, like older than me, okay, older, let's say 70s, 80s. When you age, oftentimes this idea of prune juice, the need to drink prune juice, has to do with constipation. And that's part of the aging process. Your body is breaking down, you're getting older, so you need help from other sources other than your regular fibrous diet. Maybe you need something else to help you along. Now, does age cause you to drink prune juice? No. And prune juice doesn't cause aging, but there's a correlation between how many people drink that, and there's probably and their age. You with me? So probably most older people drink this because of what prune juice does, or eating prunes even. And you don't have to be old to drink prune juice or eat prunes. They work the same whether you're old or not old. It has the same effect on your body. It would be like saying there's some relationship between, yeah. So there's this attitude that, since we're talking about bodily functions, there's this attitude and belief that the older you get, you're not interested in sex. Sex is only a young person's thing. That's not true either. There's a correlation between your sexuality and having more sex when you're young. And a lot of times it is related to procreation, wanting to have babies, and also how your hormones are. And because you can, if you're a woman or a man, a man can produce babies for a long time after a woman can. But there's a correlation between there. But it doesn't mean that youth makes you more sexual, because you can still be sexual as an older person. My prune juice example was a better example, but you kind of understand that causation. Youth doesn't cause sexuality, sexual desire, no more than sexual desire is only related to youth. There's not a causation thing there. Okay. Moving along. Now we've discussed constipation and sex. I hope you're laughing by now. Okay, here we go. Statistical projections are very problematic. They are always based on certain assumptions. So what is a projection? That's the first thing you have to ask yourself. What's she talking about? What's a projection? Is something you say is going to happen in the future. Right now, there is a lot of controversy. The controversy over climate change, or climate crisis, I like to call it, has to do with people making projections of what's going to happen. Let's take Governor Newsom's. By 2050, he wants California to be not dependent on fossil fuels, to go electric all the way. He's projecting, and other scientists have projected, by a certain year, given based upon where we're at right now in the use of our fossil fuels and the pollution that we have and all the things that are affecting our climate, by the year 2050, we will have no choice. We have to do it. So that's the statistical projections. Now, they're based on certain assumptions. Now, I ask you this early on in the semester, what are the assumptions that someone's making? So the assumptions are these ideas, these conditions. What conditions? Those projections are based on certain conditions and certain agreements. Assumptions are like agreements. What assumptions? What are they? What is the author assuming that you agree with in order to accept those statistical projections? So if you're going to project by 2050, we need to be fossil fuel free and only have electric cars on the road in California residents, you are basing it on a certain assumptions and even agreements you have with your audience, that they agree that this is a problem. All right, here we go. Next one. Graphs. How graphs are laid out is important. And more so, you want to ask yourself, how you look at the graphs, right? How they can, this is the point, is that it can fool you depending upon how you look at it. Although, as this graph shows, it shows the same thing. But how you look at it, one looks like it's happening rather quickly, and the other one's happening, it looks like it's happening slow over time. And it's the same graph. It's just the way the graph is laid out. So let's go to this. You're looking at the graph. Now what you have to ask yourself is you have to look at the entire graph, not just that period, right? You have to look at the entire thing. And this one shows right here, the one on your right shows 0 to 15, but rather than the other one says 0 to 12 and has a lot more gradations between it, 0 to 2, 2 to 4, 4 to 6, 6 to 8, and so on, up to 12. So when they're looking at those 2-year periods and those increments, they're actually looking at it in a more specific, detailed manner. And this is looking at the same stuff in 5-year increments. That's going to matter in terms of even how you put that out, how you show that, and why are they showing it that way. Okay. When we say statistics are significant, or something is significant, when we say it doesn't mean that it's statistically significant. What do we mean by that? It means that significant has to be something that stands out. And you have to again ask yourself, what's the group that they're taking the statistics from? And what is it significant in comparison? The word significant calls to mind, you have to have a comparison. If you're going to say, for example, let's go back to climate. One of the arguments around climate change or climate scientists are saying they look at the time in, like, let's say 1960. Actually, a lot of them look at the industrialization period and the industrialization of the United States and how quickly climate has changed since then. Now, the only way they can establish that's significant is to look at a period before that. Before, if they're going to look at like causation or looking at what has contributed to this, they could say it's likely that this contributed because before we had this, the change in climate was really, really slow. You with me? So in order for something to be significant, you have to be able to show something in relationship to something else. Okay, keeping that in mind when you're looking at statistics. I'm looking at the time. Okay, we're going to have to stop there. We're going to end up having a third video. It's cool. I hope this has been really helpful to you, and I will see you in just a second.